Hey everybody, it's Mr. Seward, and today we're going to be talking about torque, and this is it's 321 in the SIM curriculum. And torque, and this is tau, that's the symbol for torque, is a twisting force on a shaft. And torque is measured in either foot-pounds or in inch-pounds. And the formula for torque right here, tau, is equal to the distance times the force times the sine of the angle. Now, we're going to be applying our forces at 90 degrees. And what that allows us to do is it allows us to simplify the formula, because the sine of 90 degrees, this is, I think they call this theta. This means angle. So sine of the angle, and if it's 90 degrees, sine of 90 is 1. So you can actually simplify this formula down to torque is equal to the distance times the force. And that shows us, this little animation just showed us the force pushing on it. It's at 90 degrees to the distance. That gives us the ability to use distance times force. So if we have a 116-pound force applied to the end of a lever that is 2.4 feet long, the force is applied at an angle of 90 degrees to the lever. So what is the torque that gets produced? So I'm going to show you my camera. Here we go. And I'll enlarge this thing up and move my mouse out of the way. So the first thing we have to do in any of these calculations is actually calculate the force, or the torque. So 1. And our torque formula is squiggly t, or tau, is equal to distance times force. So from our problem, we know, and I'll just tell you this right now, that our distance, so our torque, is going to be equal to the distance, which was 2.4 feet. Okay, and the force is weight, so force is going to be equal to the weight, which is 116 pounds. So substituting these values into this formula, we get that tau is going to be equal to 2.4 feet times 116 pounds. So if I get my calculator here, I'm going to take 2.4 times 116, and that equals 278.4, and that is going to be foot-pounds, so 278, and we're going to round these down or up, whichever way you have to, and that is going to be a unit of foot-pounds. All right, so that's the first thing we have to do our calculation of this thing. So I'm going to shrink this right down. So here we go. Here's the problem. 2.4 feet, 116 pounds of force. The angle is 90 degrees, so we know that that's a value of 1. So we can just use our D times F formula here. Distance is 2.4, formula, or force is 116, and this is what I just showed you on the paper. Now, it says, using the previous problem, how much horsepower is going to be generated if the force is applied at a rate of 42 RPMs. When you convert torque to horsepower, that's not as straightforward as foot-pounds per second. The angular velocity of torque is measured in radians per seconds. So we have to convert RPMs into radians per second. So I'm going to show you how to do that on this page right now. So the first thing is this is the part where when we're converting power, we have to, or when we're converting to horsepower, this is the first step. So I don't know, we'll call this 1B, I guess. And we're going to use this 278 value right here. So let me get back to my camera. There we go. All right, so 1B. So we're going to calculate first the angular velocity. Now, angular velocity, I'm going to write this down. Is the symbol W. I don't know how else to substitute it in, or how to say it, but that is actually angular velocity. It's not work. So I'm going to take this 42 RPMs that they were just talking about, and I'm going to set this up like this. So this angular velocity is equal to 42 revolutions per minute. Okay, and that's going to be multiplied times 1 minute over 60 seconds. And I'll close that parentheses because there's 60 seconds in 1 minute. Now, what we're going to do is we're going to take this next part is where we're going to convert to revolutions or radians, sorry. And the conversion for that is going to be 2 times pi radians over 1 revolution close parentheses. Okay, so this is the big part of this, and you have to remember that this is over 1 right here. All right, so we got to start canceling stuff out. Revolutions cancels out with this guy here. Minutes calculates cancels here. So when we do the calculation here, and I'm going to show you how to do this. Okay, I'm going to take and I'm going to do the 2 pi first. So I'm going to take 2. Oopsie. All right, I'm going to take 2. I'm going to multiply that times pi, and that's going to equal that. Okay. Then I'm going to multiply that times 42 equals 263 point all the rest of that. And then I'm going to divide that by 60. And that is going to give me a value of the angular velocity is going to be equal to 4.4 radians per second, because we still have radians here, we still have seconds here. Okay, now So we've got our torque calculated, and we have our angular velocity calculated. So now I'm going to draw a line across here. Okay. Now we're going to take and we're going to continue on in our formula. I'll switch to another colored pen, and I hope there's not many more steps left. I'm going to have to recycle my colors on pens. Anyways, all right, now we got to convert this to power. And so this is 2B, just to stay with my naming convention. And the power formula is that P is going to be equal to tau, or torque, times angular velocity, which we just calculated up here. So we've got our torque and we got our angular velocity calculated already. So power, I'll write this down here, it's going to be equal to the 278 foot-pounds. I'll circle that just so we know where it is, right? Circle this one too, because those are the numbers we're going to use. So our torque is 278 foot-pounds. So I'm going to take my 278 foot-pounds, and I'm going to multiply that times my angular velocity, which is 4.4. I always mix up my radians per second, my uppercase and lowercase. Okay. When I multiply those two out, so I'm going to take and cancel this, I'm going to multiply 278 times 4.4. So 278 times 4.4 equals 1,223. So the answer here is going to be that P is going to be equal to 1,223, and this is going to be foot-pounds per second. Okay? All right, back to my dark blue pen. Last part of this calculation. Remember, in our problem, they're asking us how much horsepower is being generated here. So our horsepower calculation, essentially you're going to take our value for P here, and you're going to divide that by that conversion factor that we learned about in the last lesson, which is 550 foot-pounds per second. So I'm going to write this out. So P is going to be equal to 1,223 foot-pounds per second times 1 over 550 foot-pounds per second. So our foot-pounds cancel out per second. This is 1 HP up here. Sorry, I forgot that. So if I take 1,223, and I divide that by 550, that equals 2.2 horsepower horsepower. And that is our final answer for this problem. So that's how you calculate regular horsepower. So what I'm going to do is I'll go back to my my spreadsheet, or my PowerPoint, and we'll run through this thing. That's what I just showed you. Now, this last problem here is we have a shaft that has a force of 32 pounds applied, and it's 5.2 feet from the pivot point. What is the resulting torque? So all you're going to do here is you're going to multiply that 32 times 5.2, because it's the distance times force, and that's going to give you some value. And then you're going to use that value down in the next part of the question, the second part, which is how much power, and they're talking about horsepower here, is generated if the torque is produced at 2,850 RPMs. So here we go. These, I'm not going to do this one on paper, but I'll show you this on the PowerPoint here. So we have a force of 32 pounds. The distance is equal to 5.2 feet, and our rate of rotation is 2,850. So we first calculate tau, or torque, which comes out to 166 foot-pounds. Then our next thing is we have to convert our RPMs to radians per second. So we take 2,850, we multiply that times 2 times pi, so we do 2 times pi first, and then multiply that times 2,850, and then divide that by 60 seconds. And that's going to give us 298 radians per second. Then we substitute in torque and the angular velocity, and you end up with 166 foot-pounds, which is up there, to multiply times 298 radians per second. That's going to give you 49,468 foot-pounds per second. And then you're going to convert that to horsepower by taking 49,468 and divide that by 550. It comes like to 89.9 something, so I just rounded that up to 90 horsepower. So that is going to be the calculations, or that's how you calculate torque or horsepower. And right now I'm looking to get back to, I found it. Here we go. These are the torque calculations. You have to get 2 out of 2 correct on this. I hope that this won't really cause you a lot of duress. Just follow the steps that I showed you, and you should be fine. The first problem here is just asking for torque. It's not asking for anything more. And then the second one is asking for horsepower. And I'll type the word horsepower in here right now so that we make sure that you remember to do this as horsepower. Okay? Whoops. I guess it's one word. All right. So that'll be the assignment. It'll be in the Google Classroom. And thank you very much.